We're going to compare 3 different blockchain SDKs, specifically how they wrap the key value data store that holds the on-chain storage. So we're going to look at Near, Soroban, a new blockchain from the Stellar people, a new smart contract platform from the Stellar team, and CosmWasm, which is a smart contract plugin for a Cosmos blockchain. So Cosmos lets you write your own blockchain. If you want to support smart contracts on that blockchain, you can install the CosmWasm module, and then CosmWasm also handles actually authoring the smart contracts in Rust, which compile to Wasm. All of these use Rust compiled to Wasm, WebAssembly, Wasm perhaps. All right, let's get into it. So first, we're going to compare simple incrementers. So all of these, all they're doing is storing a value, an I8 in this case, a signed 8-bit integer. You can get the number and you can increment the number. And in some cases, you can decrement it. So this is how Near does it. You need to import Near bindgen from Near SDK. And again, for all of these, you would add their SDK to your cargo toml. So Near SDK, Near bindgen, and then you have this struct at the top level. And this struct, we could rename it if we wanted to something perhaps more clear, like, let's see, we'll name it contract. So, and then the thing that it's storing is a counter. So we wrap this in Near bindgen, and we also need to wrap it in Borscht deserialize, Borscht serialize, and we are deriving default. We'll look more at that in a minute. Borscht serialize and Borscht deserialize, to me, seems like it should be something that Near bindgen could handle, but for some reason Near gives you the flexibility to replace that. A little bit strange, but this is telling, the serialization stuff is telling Near's runtime how to actually take the bytes from your contract and store them as data. So this struct will be serialized using Borscht and then stored in the key value store. The key is going to be state, and the value is going to be this whole struct represented via Borscht. And the way it's actually represented is that counter field name that you see here in the code is not going to be stored. It's just going to be 8 bits for the 8-bit integer. And then whenever you deserialize, it's matching it back up based on where it is in the struct. So if you add another field, like, I don't know, admin is a string, which isn't how you would actually want to store that. But anyway, for the sake of example, if you did this, of course, other things are going to start complaining. We can see all of these other fields are now complaining. But anyhow, if you added this and you had already stored state in the contract, whenever you try to deserialize it, big problems. So it's nice that it's not taking up extra space for all the field names, but it does make it a little bit finicky, a little bit brittle. You have to know how to migrate the state of your contract. Oh, I changed val, right? It used to be called val, now it's called counter. So this is now going to return counter, and here whenever we increment, we have to change it to counter plus equals 1, and everywhere we see val, we have to change it to counter. All right, so that should be good. That's a simple Near contract. And then the Near bindgen stuff handles actually, all the parts where it makes it work over RPC calls, where someone is going to be calling this via RPC from a web app, something like that. And that RPC call goes to one of the validators running the whole blockchain, and then it has to get turned into the input for this contract. So Near bindgen handles all the stuff that makes a smart contract a smart contract. This is I like to call them hash bracket macros. There are other kinds of macros like this log, more like a function macro. Rust seems to just call them all macros. So anyway, this Near bindgen hash bracket macro wraps the struct, and then it also needs to wrap the implementation for that struct, where you add all of your methods. And if they're marked as public, then they are the methods that people can call. So this one is actually published on rain.dev admin. This incrementer is counter.raindev.testnet. So we can get the num and see that it's 21. We could sign in, increment, decrement. Anyhow, let's move on to Soroban. So Soroban, like I said, new blockchain, new smart contract platform from Stellar Classic, if you will, doesn't support full smart contracts. Soroban does. So here we have this counter, which is a symbol, and we use the symbol macro. Probably, since it's a const, we need the actual declaration there. It'll get mad if we don't have it. So anyhow, counter is a symbol. It's wrapping this string slice. We're not using standard library, no STD. So the Rust has string slices. This is a string slice. The symbol is turning it into an in-memory symbol when the contract is actually running. Contract implementation. Oh, it doesn't like I8. We need to change I8 everywhere to I32, say. And now contract impl is happy. So that's probably just because Soroban is very new. They're still working on it. So here we can see this symbol. So in memory, a symbol is kind of string-like. You can do some string-like things with it, but it is a 64-bit in-memory address. And it's called a field or a value type, I think, if I'm remembering correctly. And then when that's actually stored, you can see that the Soroban has this very kind of straightforward access to the key value store. You sort of see the key value store here, where in Near SDK, it's kind of magically hidden. So env.data get counter is going to return an option. Here, I'll turn on line wrapping. So a sum or a none wrapping a result, which is an OK or error. So then we unwrap the option. If it's none, that means there is no value. So we default to a result, OK0, and then we unwrap that result. If it's an error, the counter was not an I32, and so the unwrap panics. Otherwise, it unwraps the OK and just returns the 0 inside, matching I32. Great. So when we increment, it's the same thing, just one line without comments. So env data get counter, unwrap, or OK, and then we unwrap again, and then we env data set counter to counter plus 1. So this is a very straightforward get, set, key value, like wrapper around the key value store. CosmWasm. CosmWasm has the most opinions about how you write your code, and it's kind of nice patterns, nice conventions that you probably need with a contract of significant size, unlike something like an incrementer. And usually CosmWasm gives you a bunch of files in your source contract. You've got messages and errors, a state.rs, and contract.rs stores the logic that pulls them all together. So here I moved them all into one file just so we could sort of do an easier side-by-side comparison. But the main state stuff is here. So we've got the pub struct state with a count of I8. We can use I8 again. And then pub const state is an item. And this item comes from CW CosmWasm storage plus. An item has one typed item at the given key. So this is a little bit in between the two, right? It's kind of some of the explicitness of Soroban with some of the higher level declarations that Near gives you, I guess. So you've got this struct, and something I like about Near and CosmWasm is that you can see what kind of value is stored at that key, right? So you're saying the thing with this storage key state, so this is the actual storage key that's going to be put in the key value store, is going to have something of this shape stored in it. And here I'm actually I haven't investigated yet how the data is serialized. It seems to be using serialized and deserialized. Oh, it's using JSON. Look at that. It was really easy to figure out. So instead of Borscht, or something more storage efficient like that. CosmWasm is kind of wasteful with its space using JSON. And the reason the near team didn't use JSON is that it's not that efficient, and also the order of the keys can change, right? There's the same data, the same serialized data can be deserialized into multiple correct forms. There's no one-to-one deserialization. So I don't know if that causes problems in CosmWasm, or if maybe there's somehow, maybe Serday is more careful than that. I'm not sure. It might be, they might get away with it because of quirks in Serday. Anyhow, so this looks pretty similar to near, where we store this struct, but unlike near, where the key in storage is implicit, where it's just always state, all caps. Here you can give it state, or you could just say s, and you can have multiple items, right? So we could have pub const other state is an item that stores, I don't know, whatever else, right? And we can have multiple top level keys, which means that you can deserialize one without deserializing both, or deserializing all of them. In near, that's actually not true. If you try to deserialize, like anytime you have this and self here, the contract gets access to this entire struct. So if your struct has a whole bunch of values, you are deserializing every single one of them anytime you try to deserialize anything, right? Any method that needs access to any state ends up deserializing all of the state. That's not true in CosmWasm. That's obviously not true in Soroban. So that's a quick look at sort of simple contracts. If you want to go a little bit deeper, check out the linked blog post in the show notes, or maybe you're already watching this there. But it also compares more complex contracts, more complex storage, so you can see how each of these SDKs wrap for sets of data, whole arrays, vectors, lookup maps, whatever kinds of sets of data. You can see how they do that too. Thanks for watching.